Let's take a look at this question. A PN junction solar cell of area 1 cm square illuminated uniformly with 100 mW per centimeter square has the following parameters. Efficiency of 15%, open circuit voltage of 0.7 volt, fill factor 0.8 and thickness 200 micrometer. It's asked to calculate the average optical generation rate. For detailed explanation regarding solar cells, watch the NPTEL course, The Design of Photovoltaic Systems by Professor Umanand, IISc. Let's take a look at some of the parameters that are mentioned in the question. First thing is the open circuit voltage. When the solar cell is not connected to any load, the voltage across it is maximum, termed as the open circuit voltage with a zero current. And the short circuit current, that is, when the ends of the solar cell are shorted, the voltage across it is zero and then the current flowing through it is maximum and is termed as the short circuit current. And looking at the fill factor, before that, let's take a look at the IV characteristics of the solar cell. The span of the IV characteristics of the solar cell ranges from 0 voltage and short circuit current and open circuit voltage and zero current. But as we already know, these 2 points do not generate any electrical power. But there is a point which generates maximum power and is termed as a maximum power point. So the fill factor basically describes the relationship between the maximum power that the solar cell can produce to the product of the open circuit voltage and the short circuit current. So from this, when we see it, it's basically this area over this area. So higher the fill factor, the higher power the solar cell can provide. But typically the values of fill factor range from 0.7 to 0.8. And efficiency is straightforward. Efficiency gives the ratio of the maximum power generated by the solar cell to the amount of the solar irradiance hitting the array. Okay, so now that we have learned what each of these terms mean, let's go ahead and solve the problem. Okay, so we define the average optical generation rate as the short circuit current over the charge into area into thickness. So let's take a look at the given data. So we have efficiency of 15%, open circuit voltage 0.7, fill factor 0.8 and thickness as 200 micrometer. The only value that we need to calculate the average optical generation rate is the short circuit current. Start by calculating the amount of input power. So it has been mentioned in the question that the solar cell of area 1 cm square is illuminated uniformly with 100 mW per centimeter square. So that would be the total input power is the rate at which it's being illuminated, that is 100 over an area of 1 cm square, that would be 100 milliwatt. Alright, so and it's also given that the efficiency is output power over input power into 100. That is 15 equal to output power over 100 milliwatt into 100. So from this we know that the output power is 15 milliwatt. Okay, so we have also learned that the fill factor is the maximum output power over the product of the open circuit voltage and the short circuit current. So that would be 0.8 is equal to 15 milliwatt over 0.7 into short circuit current. So when we calculate this, the short circuit current evaluates to 0.027 ampere. So now that we have the short circuit current, let's go ahead and calculate the average optical generation rate. That would be 0.027 over 1.6 into 10 power minus 19 into area as 1 cm square and thickness 200 micrometer. And this comes around 0.84 into 10 power 19, which is option B.